Hello class 9. Let's learn about triangles, especially based on congruency. Triangles are closed figures or polygons formed by three intersecting lines. By the word tri, we mean three. A triangle has three sides, three angles, and three vertices. For example, in a triangle ABC, denoted as ABC, where AB, BC and CA are the three sides, angle A, angle B and angle C are the three angles, and A, B and C are the three vertices. So these are all the parts of a triangle. The polygons which have same shape and size are known to be congruent to each other. We are allowed to flip or slide or turn to check the congruency of two figures. Let us take these two examples. So we can see we have two rectangles over here, but we can clearly see that even though they are rectangles, that is, they have the same shape, but they are of different sizes. So therefore, they are not congruent. Again, if we take one more example, here we can see this is another rectangle, but again it is not equal in size with the other two rectangles. So again, these three are not congruent to each other. To check whether two figures or polygons are congruent or not, we can superimpose the figures like this. But we can see they are not exactly equal on each other. We can also try this, but see, we can see the second diagram over the first one. Therefore, we can say that these two are not congruent or exactly equal to each other. If we look out for more examples, we can see these two rectangles again. So we can see that the shape is definitely same, but the size also seems equal. So we can say that they are congruent to each other. But let us superimpose these two pictures and see whether these two polygons are congruent or not. We can see that they are exactly fitting into each other. So therefore, we can see that these two are congruent to each other. We can also take examples of triangles, but here we can see that at a glance, we can say that they are not congruent to each other. But if we just check like this, obviously they are not congruent, but if we just turn it a bit, we can see that they are exactly equal to each other. So thus we can say that these two triangles are congruent to each other. So thus we can say that congruent polygons or shapes are such kind of figures which are same in shape and as well as same in size. That is, they are just the copy of. Let's define the congruency of triangles. Two congruent triangles has equal corresponding angles and equal corresponding sides. Let us take two congruent triangles, triangle ABC and triangle XYZ. So for these we can see that for these two triangles ABC and XYZ, we are having corresponding angles and corresponding sides. What do you mean by the word corresponding? Obviously, all the sides and all the angles are not equal to two triangles. We can take equilateral triangle, we can say all of the angles and sides are equal. But if we take an isosceles triangle or a scalene triangle, obviously all the sides cannot be equal or all the angles also cannot be equal. In such cases, we can say angle A is equals to angle X. So, angle A of triangle ABC is equal to angle X of triangle XYZ. But no other angle is equal to angle A. So, since these two angles are equal, they are corresponding to each other. Similarly, angle B is equals to angle Y means that here angle B is equal to angle Y and they are corresponding to each other. Similarly, AB equals to XY means the side AB right here of triangle ABC is equal in size with the side XY of triangle XYZ. So these two have equal length. Similarly, side BC is equal in length with side YZ and AC is equal in size with XZ. Since we have these conditions, therefore we can say they are corresponding sides and they have corresponding angles. So it is very important that two triangles will have corresponding angles equal and equal corresponding sides. It's mandatory that if two triangles are congruent, that means they must have all the congruent sides or corresponding sides equal and the corresponding angles equal. Otherwise, they will not be congruent to each other. Or if it is said that two triangles are in such a manner so that they have these equal angles and equal sides like this, then we can say that they are congruent to each other. So this is the way how we denote two triangles to be congruent. This is the congruent sign. So triangle ABC is congruent to triangle XYZ. Now, while naming the triangles, if we say the first triangle is ABC, then we have to name the second one as XYZ. The reason is angle A is equal to angle X. Just the condition right over here says angle A is equal to angle X. So at whatever position we write down the vertex A, we have to write in the same position the same vertex X or the equal vertex X. So angle B is equal to angle Y. So in the second position we have B. So in the second position we will write down Y. Similarly, angle C is equal to angle Z. Therefore, since angle C is in the third position, we will write down Z in the third position. If we have the sides given in a particular sum for two triangles, that these sides are equal, how can we name them? So we can see that in the first condition we have AB equals to XY and BC is equals to YZ. So in these two equations, the left hand side has B and then the right hand side has Y. That means the vertex B is equal to the vertex Y. That means wherever we will write B, there only we will write down Y. So from here we can write down AB is equals to XY. Since we have written AB, we will write here XY. BC is equals to YZ. So BC in the second and third position. So here also in the second and third position, we'll write down YZ. And for checking, AC equals to XZ. So A in the first, C in the third. Here also X is in the first and Z in the third. In this manner, it is very mandatory to write down the name like this. If you write down the names of the triangle as triangle ABC is congruent to triangle YXZ, this will be completely wrong because angle A is not equal to angle Y. Ultimately, that part would be wrong. So it is very important that we focus on this part. Now, whatever be the corresponding sides, if we have any particular condition like so, and we want to conclude some other relation, suppose we know that all the sides, corresponding sides are equal, therefore we can say that they are congruent, and if they are congruent, then their corresponding angles are also equal. So for writing such things, we can write down corresponding parts of congruent triangles. That means AB and XY are corresponding parts. BC and YZ are corresponding parts. So we can write in short corresponding parts of congruent triangles to be CPCT. The first letter of every word here. CPC. There are a few criteria for which we can prove two triangles are congruent. So we do not really have to prove every time all the angles and all the corresponding sides are equal. All the 6 criteria are not required to be proved or proven, but we can get few criteria based on which we can say that yes, these are congruent to each other. So the first one is SAS. S stands for side, A stands for angle, and S stands for side. Side, angle, side. That means SAS, congruence rule. Next one is the ASA or angle side angle congruence rule. AAS, that is angle angle side congruence rule. Side 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 or SSS congruence rule. And RHS, right angle hypotenuse side congruence. So these are the 5 criteria based on which we can prove two triangles are congruent or not. We do not have to go for all the 6 properties. To start with, SAS congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle. We have to focus over here. That is two sides and the included angle. That means two sides and the angle between them. This is very important for this rule. So if we take the triangle ABC and PQR, we can clearly see that AC is equal to PR. AC is given as equal to PR. Then angle C is equals to R, angle C is equal to R, and BC is equals to QR. The side BC is equals to QR. So these are the conditions which are given. From here what we can see is two sides of this triangle is equal to the two corresponding sides of the other triangle. And also the angle between them or included between these two sides is equal to the angle between or included between the corresponding sides. So since we are having these two in between the corresponding equal sides, therefore we can apply this rule. Because from the first condition we are getting one side, then the angle between them for that A, and the third side or the second side for that S. SAS rule. So in triangle ABC, we can write these conditions and we can see the SAS rule is valid right here. Now, if you say that angle C is not equal to angle R, but angle C is equals to angle P, in such case, we can't say that it follows the SAS rule. Why is it so? Because it is strictly told that the angle should be included between the two sides. That means if these two sides are equal, the angle which will be equal will always be in between them or included between them. Therefore, we cannot choose any other angle. So for any triangle, if we have an angle equal to this one, which is not in between these two sides, then we will not be able to apply the SAS rule. So it is very important. Now, since for this case, we are having valid corresponding sides and angles, therefore we can say that triangle ABC and triangle PQR are congruent to each other by SAS congruence rule. Next, ASA congruence rule, that is angle side angle congruence rule. By this rule, we can say two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. This is just the opposite of the previous case. Here, two angles will be equal. Here angle A is equals to angle D. Here angle C is equals to angle F. And between these two angles, we have the side AC. And between these two angles, we have the side DF. So if these are equal, then only we can say that we can apply the ASA rule. See, in triangle ABC and DEF, we can see that angle BAC is equals to EDF. So BAC is equals to EDF, right? For that, we can take the condition angle. Next, the second condition says that AC is equals to DF. For that, we have a valid side. And then angle ACB is equals to angle DFE. So ACB is equals to DFE. So we can see that two angles and the side between them. Again, two angles and the side between them. So we can apply the angle side as well. Therefore, we are valid with the ASA rule, angle side angle congruency rule. But if in these two cases we can see that angle A is equals to angle D, angle C is equals to angle F, but AC is equal to say ED, then we can't apply the ASA rule, because for the second triangle we will not have the side or the corresponding equal side which is between the two angles. Okay, but in this case it is between the two angles, and it should be between the two angles, but maybe if DE is equal to AC, then it will not follow. Therefore, in that case we will not take the ASA rule. So it is very important to keep in mind. But for these conditions, we can see that triangle ABC and DEF are following the ASA rule. Therefore, we can say that triangle ABC is congruent to triangle DEF by ASA. Next, AAS congruency. Two triangles are congruent if any two pair of angles and one pair of corresponding sides are equal. This one is quite reluctant. It says that you can choose any two pairs of angles. It can be these two, it can be these two, any two, and one pair of corresponding sides. So it does not have to be between those two angles. Okay, you can take any two angles and any side can be equal. But for that case, we have to name it AAS, angle angle side. If you say ASA, that means those two angles will have the equal sides in between them. But when we say AAS, that means you can take any two angles and any one side, corresponding sides which are equal. So in triangle ABC and PQR, we can see that angle BAC is equals to QPR. BAC, this one is equal to QPR right over here. So see, single arcs are there, that means they are equal. Here double arcs, that means they are equal. So we can take the rule A, or for angle. Another angle is also equal, that is CBA is equals to RQP. CBA is equals to RQP. So these two angles are equal. Then we have BC is equals to QR. We can see BC does not lie between the two angles, but no problem. Here also RP or RQ does not lie between the two angles. So we can take any two angles, here any two angles and any one side can be there. So if that is the case, then we can say that by AAS congruence rule, triangle ABC and PQR are congruent to each other. SSS congruence rule, right by the name we can see that if three sides of one triangle are equal to the three sides of the another triangle, then the two triangles are congruent, right? So if we take two triangles ABC and PQR, we can see AC is equals to PRC, one slice. Again, BC is equals to QR, 2 marks right here, and AB is equals to PQ, 3 marks here. This is how we denote in a diagram. Okay, so we can see that the three corresponding sides are equal here. Okay, we can also turn it in some cases if it is given in the question as such, but here it is given in triangle ABC and PQR. AB equals to PQ, a side, then BC equals to QR, another side, and CA is equals to RP, that is the third side. So all the three sides are correspondingly equal to each other. So therefore we can say that triangle ABC and PQR are congruent by SSS congruence rule. Now the last condition or criteria, that is the RHS congruence rule. This is a very unique one because it is only stuck to right angle triangles. So if in two right angle triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. So let us take two triangles ABC and DEF. So we can see that both of them are right angle triangles. So when we say RHS, that means right angle, hypotenuse and side. So first we'll look out for right angle. So here we can see right angle B and E are both 90 degrees, which are right angles. Fine. Then the hypotenuse should be equal. So opposite to the 90 degree is the hypotenuse for every right angle triangle. So opposite to angle B we have AC and opposite to E right here we have DF. So AC and DF has to be equal. So here we can see by the given condition AC and DF are equal. So we are going for the H condition as well, that is the hypotenuse condition. And then we have the third condition, that is any one side. Any one side except the hypotenuse can be taken. It's not that the base will be taken or the perpendicular will be taken, not so. We can take any one. Okay. So here it is given that BC is equals to EF, BC is equals to EF. We can also take BC is equals to DE. Won't be any problem. But in this question, since BC equals to EF, we will write it like so. And therefore that will be equals to S. So hence we can say, thus we can see that by the RHS congruence rule, triangle ABC is congruent to triangle DEF. Thank you everyone for watching the video. Hope it was helpful and you could understand the concept of congruency. Thank you. Bye bye.